Hello, hello, hello. It's time for another stream. Hope everybody is having an amazing day. Hope you have something good to eat, had some nice sleep, and just generally have had a good day. And if it's the start of your day, I hope it will go good. For me, it's been the same as usual. Went to the gym, drank some protein, and luckily, nothing bad has happened with the internet yet. I feel like I'm gonna get hit with some karma today, now that I have said that, but let's hope it doesn't happen and we have a good stream without anything wonky happen. So yeah, today it's more of the same. We read the coding roadmap, then we draw, and then we continue with Elden Ring, and I'm going to be Melania today. It's something I have to do, because after that I gotta find that teleporter so I can get to Moog, so I can beat him and be ready for the DLC, which hopefully I will be able to start next week. Because on Friday, if I remember correctly, I might be wrong about this, it's Midsummer, and I'm going to celebrate that with my family. So, of course, I don't stream on Friday, Saturday, and Sunday either way, so that doesn't really matter in terms of when I stream, but on Monday we will start the Elden Ring DLC, which will be fun. So yeah, today we're gonna beat Melania, then we're gonna find Moog and either beat him today or tomorrow, depending on how long Melania takes. And yeah, apart from that, nothing else will probably happen today. So yeah, we start with code roadmap, then we go into drawing, and then we play game. So yeah, with that, let's start. So let me quickly check something before I do that. Alright, both YouTube and Twitch seems to be going strong. Alright, let's jump over to the roadmap in 3, 2, 1. Alright. As yesterday, we were able to get through a bunch more of this. We went through this one, and this one. So today, we're on to this, which seems to be pretty interesting. So yeah, with that, let's start. Structures and classes. Alright. Structures and classes are user-defined data types in C++ that allows for the grouping of variables of different data types under a single name. They make it easier to manage and organize complex data by creating objects that have particular attributes and behavior. The main difference between a structure and a class is their default access specifier. Members of a structure are public by default, while members of a class are private. Okay. Structure. A structure is defined by the struct keyword, followed by the structure's name and a set of curly brackets, enclosing the members, the variable, and or function of the structure. The member can be of different data types. To create an object of the structure's type, use the structure name followed by the object name. Here's an example of defining a structure and creating an object. Okay. Alright. You can access a member of a structure using the dot operator. Alright. Okay. I think I get this. A class is defined by the it's defined using the class keyword followed by the class name and a set of curly brackets, enclosing the members, variables, and or functions of the class. Like structures, class members can be of different data types. You can create objects of a class using the class named followed by the object name. Here's an example of a class defined in an object creation. Alright. Let's look through this. Okay. Alright. Since the data members of a class are private by default, we cannot access them directly using the dot operator from the outside of the class. Instead, we use public member functions to set or get their values. Alright. That's a brief summary of structure and classing in C++. Remember that while they may seem similar, classes provide more control over data encapsulation and can be used to implement more advanced features like inheritance and polymorphism. I have no idea I know what inheritance is, but I have no idea what this word actually means. Alright. Now, since the purple ones are intermediate, I'll continue down this path and then I'll go back to do these. Object-oriented programming. Object-oriented programming, OPP, is a programming paradigm that uses objects, which are instances of classes, to perform operations and interact with each other. In C++, you can achieve object-oriented programming through the use of classes and objects. A class is a blueprint for creating objects. It defines the structure, data members, and behavior member functions for a type of object. Here's an example of a simple class. Alright. Alright, I see. This dog class has two data members, name and age, and one member function, bark. You can create an object of this class and access its members like this. Alright. That's interesting. Encapsulation. Encapsulation is the concept of building data and functions that operate on the data within a single unit, such as a class. It helps to hide the internal implementation details of a class and exposes the necessary information and functionality in C++. You can use access specifiers like public, private, and protected to control the visibility and accessibility of class members, for example. Alright. In this example, we made the name and age data members private and added public member function setName and setAge to modify them. This way, the internal data of the dog class is protected and only accessible through the provided functions. Alright. Inheritance. Inheritance is a concept of deriving new classes from existing ones, which enables code reusability and organization. In C++, inheritance is achieved by using a colon followed by the base class access specifiers and the base class name, for example. Alright. In this example, the dog class inheritance for the animal class. Wait, let me read this again so I can focus. Alright. In this example, the dog class inherits the animal class, so the dog class can access the breathe function for the animal class. When you create a dog object, you can use both breathe and bark functions. Oh, alright. Polymorphism. Polymorphism allows you to use a single interface to represent different types. In C++, it mainly achieved using function overloading, virtual functions, and overriding, for example. Oh, I see. Alright. In this example, we have animal base class with a virtual make sound function. When we derive two classes dog and cat, which overrides the make sound function, this enables polymorphic behavior, where an animal pointer or reference can be used to access the correct make sound function depending on the derived class type. Alright. That's a brief overview of the object-oriented programming in concept in C++. Alright, that's interesting. I gotta quickly blow my nose, so I'm gonna mute. Alright, let me drink some gaming subs before I continue. Today it's caffeinated blowhole blast. Ah, so good. Alright, do I want to go up or want to go down? Well, since this one... Wait, these actually... so I guess these are different for both, alright. Let's do this one. Static polymorphism. Static polymorphism, also known as compile time polymorphism, is a type of polymorphism that resolves the types and methods calls at compile time rather than at runtime. This is commonly achieved through the use of function overloading and templates in C++. Function overloading. Function overloading is a way to create multiple functions with the same name but different parameter lists. The compiler determines the correct function to call based on the types and number of arguments used when the function is called. Alright, here's an example. Alright. Templates. Templates are a powerful feature in C++ that allows you to create generic functions and classes, or classes, my bad. The actual code for specific types is generated at compile time, which avoids the overhead of runtime polymorphism. The use of templates is the main technique to achieve static polymorphism in C++. Alright. In conclusion, static polymorphism achieves polymorphic behavior during compile time using function overloading and templates, instead of relying on runtime information like dynamic polymorphism does. This can result in more efficient code since method calls are resolved at compile time. Oh, alright. So this one is more efficient than dynamic polymorphism, which is here. Let's read this one, then go down here. Overloading of functions. Function overloading is a type of static polymorphism in C++ where multiple functions with the same name but different sets of parameters are defined in the same scope. This allows you to use the same function name for multiple tasks by providing different arguments while calling the function. The appropriate function to call is determined during compile time based on the number and types of argument passed. To overload a function, simply define another function with the same name but a different set of parameters. The compiler will automatically choose the correct function to call based on the provided arguments. Here's an example illustrating function overloading. Alright. Alright, in this example, three overload functions named print are defined. They each take a different type of argument, int, double, and character constant, I'm guessing. When calling print with different arguments like 5, 3.14, and hello world, the appropriate function is chosen based on the type of the provided argument. The output of this program will be... Alright. Keep in mind that the number of parameters and their types should be different from two functions to be overloaded. Alright. That's cool. Dynamic polymorphism. Dynamic polymorphism is a programming concept in object-oriented languages like C++, where a derived class can override or redefine methods of its base class. This means that a single method call can have different implementations based on the type of object it is called on. Dynamic polymorphism is achieved through virtual functions, which are member functions of a base class marked with the virtual keyword. When you specify a virtual function in a base class, it can be overridden in any derived class to provide a different implementation. Alright, here's an example of C++ demonstrating dynamic polymorphism. Alright, class, shape, drawing a shape. Oh, alright. This code defines a base class shape with a virtual function draw. Two derived classes circle and rectangle both override the draw function to provide their own implementations. Then in the main function, a pointer of type shape is used to call the respective draw function of circle and rectangle objects. The output of this program will be drawing a circle, drawing a rectangle. Alright. As you can see, using dynamic polymorphism, we can determine a runtime which draw method should be called based on the type of object being used. Alright. That's cool. Let's see, virtual tables or virtual methods. Which one shall I go to? Right is always right, so virtual tables. Virtual tables, or vtable, are a mechanism used by C++ compilers to support dynamic polymorphism. In dynamic polymorphism, the appropriate function is called a runtime depending on the actual object type. When a class contains a virtual function, the compiler creates a virtual table for that class. This table contains function pointers to the virtual functions defined in the class. Each object of that class has a pointer to its virtual table, or a virtual pointer, which is automatically initialized by the compiler during object construction. Alright. Let's consider the following example. Alright. 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 In this example, when a derived object is created, the compiler generates a vtable for derived class, containing pointers to its virtual functions. Derived function 1, overridden from base function 2 inherits from base. The virtual pointer in the derived object points to this vtable. When the function is called on the base pointer pointing to the derived object, the function pointer in the vtables is used to call the correct function. In this case, derived function 1, similar to function 2, calls base function 2. Alright? Since it's the function pointer stored in the vtable for derived class, note that function 3 is not part of the vtable as it's not a virtual function. Oh, alright. Oh. Alright, yeah. I see that now. Right, that was virtual tables. Now it's on to virtual methods. Virtual methods are a key aspect of dynamic polymorphism in C++, where we allow subclass methods to override the methods of their base class. So the appropriate method is called depending on the actual type of an object at runtime. To declare a method as virtual, simply use the virtual keyword in the method's declaration in the base class. This tells the compiler that the method should be treated as a virtual method, allowing it to be overridden by derived classes. Alright. God, I got a bit of a runny nose today. I gotta blow my nose again. Alright. Here's an example of demonstrating virtual methods. Alright, class shape, public, virtual double area, constant, return to 0. Derived class, class circle, public shape, circle double radius, over into the base class method. Private double radius, derived class rectangle shape, public, blah blah. Alright. Overridden the base class method. Alright. In this example, we define a base class shape that has virtual method area. This method is the overridden by the derived class circle and rectangle. By using a virtual method and a base class pointer to the derived objects, we can invoke the appropriate area method based on the actual object type at runtime. Alright. That's interesting. Alright, now we're done with this one, and now it's time to go to these three. Let me drink some gaming stuff before I start. Alright, so let's start with the rule of 0, 5, 3. The rule of 0, 0, 3, and 5 is that it's a set of guidelines for managing object resources in modern C++. Related to structures and classes, these rules deal with the default behavior of constructors, destructors, and other special member functions that are necessary for proper resource management. The rule of 0 states that if a class of structure does not explicitly manage resources, it should not define any of the special member functions. A destructor, copy constructor, copy assignment operator, movement constructor, and movement assign operator. Compiler will automatically generate these functions, and the behavior will be correct for managing resources like memory and file handles. Alright. Example. Alright. In this example, my resources is a simple structure that does not manage any resources, so it does not define any special member functions. The compiler will generate them automatically, and the behavior will be correct. Alright. Rule of 3. The rule of 3 states that a class of structure that manages resources should define the following 3 special member functions: destructor, copy constructor, copy assign operator. These functions are necessary for proper resource management, such as releasing memory or correctly handling deep copies. For example, class my resources public. Alright. In this example, my resources is a class that manages a resource, an array of integers, so it defines the destructor, copy constructor, and copy assignment operator. Alright. And now, rule of 5. The rule of 5 extends the rule of 3 to include 2 additional special member functions: move constructor, move assign operator. Wait, didn't they? No, it was copy, alright. So this one is copy, this one is move, alright. Move assignment operator. Modern C++ introduces more I gotta Google Translate this. Google Translate. Google Translate. Semantics, alright. Introduces some more semantics, which allows for more efficient handling of resources by transferring ownership without necessarily copying all the data. Alright. So this is constructor and destructor. Alright, that constructs it, that deletes it. Copy. Copy assignment operator. Move constructor. Move assign operator. Alright. In this example, my resources is a class that manages a resource, an array of integers, so it defines all 5 special member functions for proper resource management and move semantics. Alright. That's cool. Give me a minute. I don't know why, but my room is a bit harder than what I like, so I'm gonna turn on my fan. I'm gonna keep it on low. There we go. A nice little breeze. That's good. Alright. With that, now it's multiple inheritance. Multiple inheritance is a feature in C++ where a class can inherit characteristics, data members, and member functions from more than one parent class. The concept is similar to a single inheritance where a class inherits from a single base class, but in multiple inheritances, a class can have multiple base classes. Alright. When a class inherits multiple base classes, it becomes a mixture of their properties and behaviors and can be overridden or extended as them as needed. Alright. Syntax. Here is a syntax to declare a class with multiple inheritances. Alright. Alright. The derived class will inherit members from both base class 1 and base class 2, and the access specifier like public, protector, and private determines the accessibility of the inherited members. Alright. Here's an example of multiple inheritance in action. Alright, class animal, eat. I can eat. Mama 1, breathe. I can breathe. Alright. No, mammal. Wait, is that... Is that a L or a 1? Actually, I want to see. Is that a L or a 1? It was a... Alright, so it wasn't a 1. It was mammal. Got it. I do not know why, but that looks like a 1 to me. I mean, look at that. This is a 1. You see? That is a 1. And this is an L. There is not much difference there. Right, mammal. Got it. Wait a minute. Why do we... God damn it. Alright, let me ignore that part so I don't get a headache from that. Alright. Mammal, breathe, I can breathe. Derived class inheritance, inheriting from both animal and mammal. Dog, animal, mammal. Public, bark, I can bark, woof woof. Main dog, eat, breathe, bark. Alright. In some cases, multiple inheritance can lead to complications such as I have a feeling I know how to say this, but I'm not entirely sure, so... Ambiguity, alright. Ambiguity, and the diamond problem ensures that you use multiple inheritances. Jesus Christ, what is this word? Judiciously, alright. Inheritance judiciously and maintain well-structured and modular classes to prevent issues. For more information, alright. Nice. Now, diamond inheritance, which if the last part of that there was problems with this would fix it, if I remember correctly. Alright. With that, let's go. Diamond inheritance is a specific scenario in multiple inheritance where a class is derived from two or more classes, which in turn are derived from a common base class. It creates an ambiguity that arises from duplicating the common base class, which leads to an ambiguous behavior while calling the duplicate members. To ensure this ambiguity, you can use virtual inheritance. A virtual base class is a class that is shared by multiple classes using virtual keyword in C++. This ensures that only one copy of the base class is inherited in the final derived class, and thus resolves the diamond inheritance problem. Alright. Let me look through this example. Beep beep boop boop bop bop. Beep beep boop boop bop bop. Ba 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 ba. Alright. In the code above, derived 1 and derived 2 are derived from the base class using virtual inheritance. So when we create an object of derived 3 and call the print function from the base class, there is no ambiguity. No ambiguity. ambiguity, I'm just gonna say it like that, and the code executes without any issues. Alright. And with that, we're now done with this big one. Nice. I'm gonna stretch in celebration. Very nice. Give me a quick second. I gotta scratch my body a bit. Alright, there we go. And now we're on to this little guy. Exception handling. Exception handling in C++ is a mechanism to handle errors, anomalies, or unexpected events that can occur during the runtime execution of a program. This allows the program to continue running or exit gracefully when encountering errors instead of crashing abruptly. In C++, provides a set of keywords and constructs for implementing exception handling. Try defines a block of code that should be monitored for exceptions. Catch specifies the type of exception to be caught and the block of code that shall be executed when the exception occurs. Throws an exception that will be caught and handled by the appropriate catch block. And no except specifies a function that doesn't throw exceptions or terminates the program if an exception is thrown within its scope. Alright. Here's an example demonstrating the usage of exception handling. Alright. Alright. In this example, we define the function divide that throws an exception if b is 0. In the main function, we use a try block to call divide and the output the result. If an exception is thrown, it is caught inside the catch block, which outputs an error message. This way, we can handle the error gracefully rather than letting the program crash when attempting to divide by 0. Alright, I see. Standard exceptions. C++ provides a standard set of exception classes under the standard except library, which can be used as the exception type for more specific error handling. Some of these classes include standard exception, base class for all standard exceptions. Standard logic error represents errors which can be detected statically by the program, and standard runtime error represents errors occurring during the execution of a program. Alright. Here's an example showing how to use standard exceptions. Alright. In this example, we modified the divide function to throw standard runtime error instead of a simple string. The catch block now catches exceptions derived from SSD expectation and uses the member function what to display the error message. Oh, alright. That's cool. Alright, which one do I want to start with? Exit code, exception. Well, actually, since this one connects to that, let's start with exit code. Exit code, also known as return codes or status codes, are numeric values that a program returns to the calling environment, usually the operating system, when it finishes execution. These codes are used to indicate the success or failure of a program execution. 0 is standard exit code for a successful execution, while non-zero exit codes typically indicate error or other exceptional situations. The actual meaning of non-zero exit codes can vary between different applications or systems. In C++, you can return an exit code for the main function by using the return statement, or you can use the exit function, which is part of the C++ standard library. Alright, using return in main. Alright. Alright. Using the exit function, alright. In both examples above, the program returns exit code depending on different error conditions encountered during execution. The code 1 and 2 are used to distinguish between two error conditions. Alright. Now, exceptions. Exceptions handling is a method used to tackle runtime errors so that normal flow of the program can be maintained. In C++, this is accomplished by using three keywords try, catch, and throw. Try. In the try block, you write the code that can possibly generate an exception. If an exception is encountered, the control is passed to the relevant catch block to handle the issue. Alright. The catch block follows the try block and is responsible for handling the exception throw by the try block. There can be multiple catch blocks to handle different types of exceptions. Alright. And now throw. In case of error occurs within the try block, you can use the throw keyword to generate an exception of the specific type. This will then be caught and handled by the corresponding catch block. Alright. In summary, exception handling in C++ is a technique to handle runtime errors while maintaining a normal flow of the program. The try, catch, and throw keywords are used together to create structure to deal with exceptions as they occur. Alright. Alright, access violations. An access violation is a specific type of error that occurs when a program attempts to access an illegal memory location. In C++, access violations are most commonly caused by dereferencing a null or invalid pointer, accessing an array out of bounds, reading or writing in memory freed by the user or the operating system. It is crucial to identify access violations because they can lead to unpredictable behavior, application crashes, or corruption of data. Some examples of access violations are deferring null or invalid pointer, alright. Accessing an array out of bounds. Reading and writing free in memory. Debugging access violations. Tools like debugger, static analyzer, and profilers can be identified access violations in your code. For example, Microsoft Visual Studio uses the built-in debugger to identify the line of code responsible for the access violation error. Volgrind, a popular Linux tool that detects memory leaks and access violations in your C++ code, sanitizer, alright. A runtime memory error detector for C++ that can detect out-of-bound access, memory leaks, and use after-free errors. Alright. That was a quick but fun little box of things. I gotta blow my nose again. All right. And now we're on to language concept. Oh boy, this one is a big one. C++ is a powerful high-level object-oriented programming language that offers several key language concepts. These concepts provide the foundation upon which you can build efficient, reliable, and maintainable programs. Here's a brief summary of some important language concepts in C++. Alright? Variables and data types. C++ provides various fundamental data types such as integer, float, double character, and bool. Example, integer age 25, height. Alright. Double salary, character grade A. Alright. Control structure. Control structures enable you to control the flow of execution of a program. Key control structures in C++ include conditional statements, if, else, or else if, loop constructors, for, while, and do while, switch case constructor, alright. Example, if else statement, if age over 18, my bad, you're eligible to vote, else you're not, alright. Alright. Functions. Functions in C++ allow you to break down a large program into small, manageable, and reusable pieces of code. Alright. Arrays and vectors. Arrays and vectors are commonly used data structures to store and manipulate a collection of elements of the same data type. Right? Pointers. Pointers are variables that store memory addresses or other variables. They enable more efficient handling of memory and are useful for working with dynamic data structure. Example, structures and classes. And classes are user-defined data types that allow grouping of variables and functions under a single name. Alright. Inheritance and polymorphism. Inheritance is a mechanism that allows a class to inherit properties and methods from a base class. Polymorphism enables you to use a base class type to represent derived class objects. Alright. Exception handling. Alright, yeah, we use Refruvis. Provides a mechanism that handles exception runtime error gracefully using try, catch, and throw construction. These are some of the key language concepts in C++, which will help you to understand the language better and develop efficient and maintainable applications. Alright, with that, I feel like I need to go to the bathroom real quick, so I'll be right back. Alright, I'm back. Now let's continue. Alright, now with this one I will go like this, because, wait. Alright, so the gray ones are optional, alright. Since that one is start, beginner, intermediate, and the black ones are advanced. Let's go down. So let's start with automatic type deduction. Auto is a keyword in C++, language introduced in C++11, which is used for automatic type deduction. It automatically deduces the type of variable from the type of its initializer expression at compile time. Okay? The auto keyword is useful when you are dealing with the complex types or when the type of variable is hard to predict. It can help in writing cleaner and less error-prone code. Alright? Here's a simple example of using auto to type deduction. Alright. Integer my int 5, auto my auto int 5. Alright. Keep in mind that auto deduces the type based on the initializer expression, so if you don't provide an initial value, you will get a compile time error. Alright. In C++ 14, you can also use auto with function return types to let the compiler automatically deduce the return type based on the returned expression. Oh, alright. Nice. Typecasting. Typecasting is the process of converting a value from one data type to another. In C++, there are 4 different methods of typecasting. C-style casting. It is the syntax inherited from C, and it is done by simply putting the target data type in parentheses before the value to cast. Alright. Example. Oh, alright. Static cast. This is the most commonly used method for typecasting in C++. It is performed at compile time, and you should use it when you have an explicit conversion between data types. Example. Alright. Dynamic cast. This method is specifically used for safely converting pointers and reference between base and derived classes in a class hierarchy. Alright. Alright, and reinterpret cast. This cast changes the type of a pointer, reference, or an integer value. It also called a bitwise cast because it changes how the compiler interprets the underlying bits. Use reinterpret cast only when you have a deep understanding of what you're doing, and as it does not guarantee that the result value will be meaningful. Alright. So as I am right now, I should never touch this one. Alright, and constant cast. This casting method is used to remove the constant qualifiers for a variable. It is generally not recommended, but can be useful in certain situations where you have no control over the constness of a variable. Alright. Remember to use the right type of casting based on the specific situation and follow good programming practices in order to ensure a safe and efficient code. Alright. Alright, undefined behavior. Undefined behavior in C++ refers to a situation where a program's behavior cannot be predicted due to a violation of the language rules. And it is a result of various factors like unutilized variables, using pointers to deallocate memory, out-of-bound memory access, etc. The C++ standard does not define the behavior in such cases, which means the compiler or runtime system is free to handle these situations in any way it wants. Some common examples of undefined behavior are unutilized variables. Access the value of an unutilized variable can lead to undefined behavior. The value of an unutilized variable is arbitrary and depends on what was in the memory location before the variable was declared. Alright. Out of bounds memory access. Accessing memory outside the boundaries of an array or buffer may result in undefined behavior. Alright. Null pointer difference. Differencing a null pointer may lead to undefined behavior. Alright. Division by zero. Alright, so that is what we looked through on the previous one, I think, where dividing by zero, performing a division operation by zero is undefined behavior in C++. Alright. Alright. It is crucial to detect and fix the root cause of undefined behavior in your programs, since it can lead to unpredictable results, data corruption, and security vulnerabilities. To mitigate undefined behavior, you can utilize tools like static code analyzer, dynamic analysis tools, and compiler options that help detect potential issues. Alright, that's cool. Argument-dependent lookup. Argument-dependent lookup, ADL, or Coing lookup, is a mechanism in C++ that allows the compiler to search for the appropriate functions to call based on the types of arguments provided. It is particularly helpful when using overloaded functions or operators in a namespace. ADL allows the compiler to find functions in the same namespace as the arguments, even if the function is not declared as the point of use or within namespace provided. This is especially useful when working with templates or generic programming. Consider the following example using a namespace and overloaded operator. Alright. Alright. In this example, when you call count objects in main, ADL is used to find the correct operator in the my namespace because the argument object is of type my namespace : my class. Alright. And now we're on to these two here. One that's naming, mangling, and macros. I'll do this one, then go into the advanced. Alright. Oh boy, that is a lot of text. Name mangling, also known as name decoration, is a technique used by compilers to encode additional information about the scope, type, linkage, or other identifying information of an identifier, function name, variables name, etc. Within its name, the primary purpose of name mangling is the support function overloading, which allows multiple functions with the same name but different parameter lists to coexist in a single program. In C++, the compiler generates a mangle name for each function and variable based on their scope and types. The mangle name is usually formed by Google Translate. Concatenating, alright. Where was I? Come on, here. Formed by concatenating the original name, parameter types, and other information, often using a prefix or suffix. For example, suppose you have the following function. The compiler might generate a mangled name such as CEA this, which encodes the function name add and its two integer parameters. The exact rule for name mangling are implementation and platform dependent. Different compilers may mangle names differently, which can lead to incompatibilities when attempting to link together object files or library compiled with different compilers. Some tools such as C++ Felt, included in GCC and Clang, can be used to demangle a mangled name back to the original identifier, which can be useful when debugging or working with symbol tables. Alright? In general, it is not necessary for you to understand the details of name mangling when writing code in C++, as the compiler handles it automatically. However, it can affect program behavior in some cases, such as when you're using external libraries or linking object files from different compilers. Oh, alright. And now we're on to macros. Macros are pre-processing directives in C++ used by the preprocessor to perform text submissions. No, substitute. I gotta go translate this just to be sure. Substitution, got it. To perform text substitution, they are defined using the define directive, followed by the macro name and the value to be substituted. Macros can be used to define constants, create functions like macros or perform conditional compilation. Constant macros. Constant macros are used to define symbolic constants for use in code. They do not use any memory and are replaced by the preprocessor before the compilation process. This macro defines a symbolic constant pi. You can use it in your code as if it were a regular variable. Oh, alright. Oh, alright, I see. Function like macros. Function like macros are similar to regular functions. They take a list of arguments and perform text substitution. I always get those words mixed up. Alright, example, define square x. Alright, this macro defines a function like macro square that calculates the square of a number. Alright. Conditional compilation. Macros can be used for conditional compilation using the if. Is that definer or if? Yeah, whatever. I don't know how to say the long word of this or that one. So if def, if and def, if else if, and if directives. All right. Example. All right. This example demonstrates how you can use macros to control the parts of code that are being compiled depending on the presence or absence of a macro definition. All right. That's nice. Alright, now we're done with this one. Now onto this one. And with the time we have left, since it's half an hour until we move on to drawing, I say we can do this one, and maybe this one. So yeah, let's try and do that. Static cast. Static cast is one of the casting operators in C++ that allows you to convert between different data types, such as integer and float, or between pointer types. This type of casting performs a compile time check and gives an error if there is no valid conversion possible between given types. Static cast is generally the safer than C-style cast since it does not perform an unsafe reinterpretation of data and allows for better typing checking. Syntax for static cast is as follows. Alright. Example, converting between basic data types. Alright. Casting pointers of different object types in an inheritance hierarchy. Converting an integer to an enumeration. Keep in mind that static casts should be used with caution when casting pointers between different object types. If the original type of the pointer does not match the target type, the result of the cast can be incorrect or cause unexpected behavior. Alright. Nice. Constant cast. Constant cast is a type of casting in C++ that allows you to remove or add constness to a variable. In other words, it enables you to modify a const or volatile object, or change a pointer or reference to a const or volatile type. This is useful in certain scenarios when you need to pass a const variable as an argument, or when a function parameter requires a non-const type, but you want to make sure the variable remains constant throughout the code. Alright. Keep in mind that using const cast to modify a truly const variable can lead to an undefined behavior, so it is best to use with this feature only when absolutely necessary. Alright. Here's a code example showing how to use constant cast. Alright, let's see. Beep 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 beep. Beep 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 beep. Alright. Original value. Alright. In this example, we first get a const variable original value, then we use constant cast to remove the constness of the variable and assign it to a non-constant pointer, a non-constant value pointer. The modify variable function takes an integer as an argument and modifies the value pointed to by the Jesus Christ. The value pointed to by the pointer, which would not have been possible if we passed the original constant int directly. Finally, we print the original value and non-constant value pointer, which shows that the value has been modified using constant cast. Please note that this example comes with some risks and touches undefined behavior. Alright. That's cool. Alright. Let's do dynamic cast. Dynamic cast is a type of casting operator in C++ that use specifically for polymorphism. It safely converts pointers and references of a base class to its derived class and checks the validity of the conversion during runtime. If the conversion is not valid, if the object is not of the target type, it returns a null pointer instead of producing undefined behavior. Therefore, dynamic casts can prevent potential crashes and errors when using polymorphism. Here's a basic example how dynamic casts can be used. Alright. Alright. In this example, a pointer to a derived class object is assigned to a base class pointer. Then we attempt to downcast it back to a derived class pointer using dynamic cast. If the casting is successful, we can access the derived class functionality through the new pointer. Alright. And now reinterpret cast. Reinterpret cast is a type of casting in C++ that allows you to change the type of a pointer or an integer without altering the representation of the data. It is generally used when the conversion required is too low level or not supported by other casting methods, such as static cast. Using reinterpret cast should be handled with care, as it can lead to undefined behavior and serve problems if used incorrectly. Here's an example of usage. Alright. This example, we're using reinterpret to change the type of a pointer from integer to character, effectively treating the integer as an array for characters and printing each byte. Remember that when using reinterpret cast, you should be cautious about dereferencing the converted pointers. The behavior can be unpredictable and it can lead to issues such as access memory regions that are not intended to be accessed. Reinterpret cast should be used sparingly and only when low-level conversions are necessary. Alright, now we're done with that one. Nice. Alright. Now it's time to go down to this one. Standard library plus whatever that stands for. Oh, that stands for STL. Alright. Standard template library. Alright, got it. Let me blow my nose one more time before I start. Alright. The C++ standard template library is a collection of header files that provide several data structures, algorithms, and functions to simplify your C++ coding experience. The primary purpose of the STL is to save time and increase efficiency by providing a ready-to-use set of useful tools. The most commonly used features of the STL can be divided into three main categories: containers, algorithms, and iterators. Containers are the data structure used for data storage and manipulation in C++. They are classified into four types: sequence containers, associative containers, and unordered associated containers, and container adapters. Alright. Sequence containers. These are linear data structures that store elements in a sequential manner. Examples include standard vector, a dynamic array that grows and shrinks at runtime. Standard list, a doubly linked list. Standard DQ, a double-ended queue allowing insertion and deletion at both ends. Alright. Standard DQ integer, Alright, yeah. Associated containers. These containers store data in a sorted manner with unique keys. Examples include standard sets, a collection of unique elements sorted by keys. Standard map, a collection of key value pairs sorted by keys. Alright. Unordered associated containers. These containers store data in an unordered manner using hash tables. Examples include standard unordered set, a collection of unique elements in no specific order. Standard unordered map, a collection of key value pairs in no specific order. Right? Container adapters. These are containers based on other existing containers. Examples include standard Q. I'm just gonna say Q. An FIFO data structure based on the queue or list. Standard priority queue, a sorted queue based on vector or the queue. Alright. Algorithms. The STL provides several generic algorithms that can be used to perform various operations on the data stored in containers. These are divided into 5 categories: non-modifying sequence algorithms, modifying sequence algorithms, sorting algorithms, sorted range algorithms, and numeric algorithms. Some examples include standard find, standard replace, standard sort, and standard binary search. For example, to sort a vector you can use the following code. Alright. Iterators. Iterators are a fundamental concept in the STL as they provide a unified way to access elements in containers. Interiors can be thought of as an advanced form of pointers. Interiors are... no, I read that. Alright, we're here. Each container has its own interior type, which can be used to transfer elements and modify values. The most common iterator operation are begin and end, for getting interpreters pointing to the first and one past the last elements of a container respectively. For example, to enter through a vector and print its elements, you can use the following code. Alright. This is just a brief overview of the C++ standard template library. There are many other features and functions available in the STL, and familiarizing yourself with them is crucial for efficient C++ programming. Alright, so I guess I gotta look through that sometime. Alright. I think it was a bit too much to think I would be able to read through this one and this one together, so I think I will be able to... I'll do this one and then we will do these tomorrow. But before I start that, I need to really quickly go on a pee break, so I'll be right back. finally back. Now let's go through these. IO stream. IO stream is a header in the C++ standard library that provides functionality for basic input and output operations. The input-output streams facilitate communication between your program and various sources, such as the console, file, and other programs. Now, streams includes the following classes: iStream for input operations from an input source, for OStream for output operations to an output target. IOStream is a combination of iStream and OStream for both input and output operations. Alright. These classes inherit from base classes iOS and iOS base. Additionally, IOStreams define several objects that are instances of these classes and represent the standard input and output streams. Alright, send an iStream object to read from the standard input, typically corresponding to the keyboard. Count an OStream object to write to the standard output, typically the console. I don't know how to say that, so I'm just gonna say sir or seer. An OStream object to write to the standard error output, typically used for displaying error messages. Alright. And clog. No. Is that, yeah, clog. An OStream object similar to seer, but its output can be buffered. Alright. Here are some code examples on using IO streams for input and output operations. Alright. Remember to include the IOStream header when using these features. Alright. Date and time. In C++, you can work with dates and time using the chrono library, which is part of the standard library STL. The chrono library provides various data types and functions to represent and manipulate time duration, time points, and clocks. A duration represents a span of time which can be expressed in various units such as seconds, minutes, hours, etc. To create a duration, use the standard chrono duration template class. Common predefined duration types are standard chrono seconds, standard chrono minute, and standard chrono hour. Alright. Example. Alright. Time points. A time point represents a specific point in time. It is usually created using a combination of duration and a clock. In C++, there are 3 clock types provided by the chrono library. Standard chrono system clock represents the system-wide real-time wall clock. Standard chrono static clock represents a monotonic clock that is guaranteed to never be adjusted. Standard chrono high resolution clock represents the clock within the shortest tick period. Alright. Alright. Clock. A clock provides access to the current time. It consists of the following elements: time point, a specific point in time; duration, the time duration between 2 time points; and now, a static function that returns to the current time point. Alright. Converting time points to calendar time. To convert a time point to a calendar representation, you can use the asynchronous system clock to time function. Alright. This summarizes the basic functionality of working with data and time in C++ using the Chrono library. You can find more advanced features such as casting duration and time arithmetic in the C++ reference. Alright. Containers. C++ containers are part of the standard template library, the SL, that provides data structures to store and organize data. There are several types of containers, each with its own characteristics and use cases. Here we discuss some of the commonly used containers. Vector are dynamic arrays that can resize themselves as needed. They store elements in a continuous memory location, allowing fast random access using indices. Alright. List. A list is a doubly linked list that allows elements to be inserted or removed from a position or constant time. It does not support random access. Lists are better than vectors for scenarios where you need to insert or remove elements in the middle frequently. Alright. Map. A map is an associative container that stores keys value pairs. It supports the retrieval of values based on their keys. The keys are sorted in ascending order by default. Alright. Unordered map. Similar to a map, an unordered map stores key value pairs, but it is implemented using a hash table. This means unordered maps has faster average case performance compared to map, since it does not maintain sorted order. However, worst case performance can be worse than map. Okay. These are just a few examples of C++ containers. There are other containers types such as set, multiset, dequeue, stack, and QU, or I don't know how to say. Actually, let me quickly Google Translate this so I actually know how to say it. Q. Wait. So you say those two the same. So you say that one Q, and if I go to here, the Q. Alright, so you say the Q the same, those two last letters are silent, alright. Q and priority queue. Each container has its own use case and unique characteristics. Learning about these containers and when to use them can greatly improve your efficiency and effectiveness in using C++. Alright. Now, iterators, my bad. Iterators are objects in the C++ standard library that helps us traverse containers like arrays, lists, and vectors. Essentially, they act as a bridge between container classes and algorithms. Iterators behave similar to pointers but provide a more generalized and abstract way of accessing elements in a container. There are different types of iterators which you would encounter depending on their use cases. Input iterators used to read elements in a container only once in a forward direction. They cannot modify they cannot modify elements, alright? Output iterator, used to write elements in a container only once in the forward direction, cannot rewrite elements, alright? Forward iterator, similar to the input iterator, but can be used for multiple passes over the elements in a container. They cannot move backwards, alright? Reverse iterator, similar to the input iterator, but can be used for multiple passes over the elements in a container, and they cannot move forward, alright? And bidirectional iterators. These iterators offer the ability to move both forward and backwards in a container. Lists and set containers have bidirectional iterators. Alright. Random access iterator. These iterators provide the most flexible ways to access elements in a container. They can move forward, backwards, jump directly to other elements, and access elements at a given index. Alright. For most cases, you would want to start with the auto keyword and the appropriate container method like begin and end to work with iterators, alright? When working with algorithms, remember that the C++ standard library provides various algorithms that already utilize iterators for tasks like searching, sorting, and manipulating elements. Alright. Alright, two more. Algorithms. The standard template library in the C++ provides a collection of generic algorithms that are designed to work with various container classes. These algorithms are implemented as functions and can be applied to different data structures such as arrays, vectors, lists, and others. The primary header file for algorithms is algorithm. Key concept: sorting. Sorting refers to the arranging a sequence of elements in a specific order. The SL provides several sorting algorithms such as standard sort, standard stable sort, and standard partial sort. Standard sort is used to sort a range of elements first, last in non-descending order by default. You can also use custom comparisons functions or lambda expression to change the sorting order. Alright, searching. Searching refers to finding a particular element is present within a given range of elements. STL provides various searching algorithms such as standard find, standard binary search, and standard find if. Alright. Standard find is used to find the iterator of the first occurrence of a given value within the range. Alright. Example. Alright. Modifying sequences. The STL also provides algorithms for modifying sequences such as standard remove, standard replace, and standard uniq. Or how do you say this? Google Translate, please help. Unique, alright. Standard unique. Standard remove is used to remove all instances of a value from a container within a given range. Note that the function does not resize the containers after removing elements. Alright, example. Summary. SL algorithms in C++ provides a set of useful functions for key operations such as sorting, searching, and modifying sequences. The algorithm can be used with a variety of containers, classes, container classes, making them highly versatile and an essential part of the C++ programming. Alright. Now we have one more. And then we're done for today. Multithreading. Multithreading is the concurrent execution of multiple threads within a single process or program. It improves the performance and efficiency of an application by allowing multiple tasks to be executed in parallel. In C++, multithreading supports is available through the thread library introduced in the C++ 11 standard. Alright. Basic thread creation. To create a new thread, include the thread header file and create an instance of standard thread that takes a function as an argument. The function will be executed in the new thread. Alright. Thread with arguments. You can pass arguments to the thread function by providing them as additional arguments to the standard thread constructor. Alright. Mutex and locks. When multiple threads access shared resources, there is a possibility of a data race. To avoid this, use mutex and locks to synchronize shared resource access. Right? This short introduction should help you get started with basic multithreading techniques in C++. There is a lot more to learn, such as thread pools, conditional variables, and atomic operations for advanced synchronization and performance tuning. Alright, we are done for today. We did a good amount. We did this one, we did this one, and this one, and this one. And tomorrow we'll do this. Alright, nice. Very good. Now, it's time to draw, but before that, I need a quick stretch break and to refill my gamer subs and all that. So, yeah. Let me go and do that real quick. So, I'll see you soon. I'll be right back. Alright, I'm back. I have refilled my gamer subs. I stretched a bit. And now it's time to draw. So let me change the category to art. There we go. Let me pop up my Clip Studio Paint, and with that, give it a few seconds. All right, and let's move over right now. Nice. All right, now let me plug in my tablet. There we go. And there we go. Nice. Alright. Now, today, I do have a better idea as to what I want to make. So, before anything, let me quickly... Oops, wrong one. There we go. Let me shrink these down, so I have a bit more room to do what I want to do. I think there is a good place. Nice. What I want to do today is draw like ballet poses. I don't exactly know any specific ones, so I'm just gonna roll with poses that I think are ballet. But I think that would be a interesting thing to do today. So let's start. Alright, firstly, let's do one that's like both legs, well, it's in like a jump. So let's start with one leg. It will go like that. There we go. Alright, if that's one leg, let's draw the... like so. Nice. The other leg will be about here. So let me draw the main body first. Alright, nice. And now let's do the other leg. Nice. And with that, I wanna, let's see. Actually, I think this one needs to be a bit longer. Like so, maybe. There we go. And now I think I'll continue with the feet for now and wait with the rest of the body. So like so, so, so. All right, that's the lower foot, and now for the foot itself. I want it to be angled like it's pointing in that direction, so Something like that, maybe? Or, no, wait. Got it. There we go. That's nice. And now that I think about it, now that I have that leg figured out, I think it will actually look better if I redo this one and do a bit better. So let me erase this one. And let me actually focus on the rest of the body for now. Because I just realized that... let's see. If that one is there, where should the... let's see. What happens if I do this? Alright. Alright, if I try and do that... Let's try the other leg now. And this one, instead of going like that, will go a bit more down. So like that. Alright, there we go. And now for another one. There we go. And this one will go down like this. Yeah, I think that looks good. I just need to make this one bigger. Like, if I erase this. There we go. And do that. A bit smaller. There. Yeah, I think that's... Wait, I got it. Let me do that. There we go. Now since that one is going like that, this one needs to go like so. Alright, how am I supposed to do this? Let's see. How did I do it on the other one? Alright, I took it back a bit like so. Yeah, like that. Nice. And now that I think about it, if that is how it's supposed to look, this one needs to be a bit higher. This line here. There we go. And I think the same for this one as well. This one needs to be a bit higher as well. There we go. There we go, and yeah, something like that. Yeah, that looks nice. And now for the arms. Since I already think it was the since I already think that this will be the back, I forgot to mention that. The head will be looking in that direction. So let me do the head right now. With just there we go. Nice. Actually, I think this needs to go a bit more like that. And now do like that. So up there, up there. There we go. I like that a bit more. Alright, nice. Now that's finished. Now for the arms, it will follow the same form as this. So this arm will go down, this arm will go forward. So let's do it from here to about there. Of course, would you be able to see the front side of it? Let's see, if I erase that, actually, let me give it a bit more shape to it. Alright, if I do that, alright, nice. Very nice. Yeah, I think that works. Very nice. Now for hand, bam, bam. There we go. Nice. And now for this arm, I'll follow the same logic by doing about that. There we go. And I can do that better. There we go. And now... There we go. Yeah, I like that. But one last thing for this one. Yeah, there we go. I will not put eyes on this one. And actually, let's make this a bit straighter. I give him a bit too much shape. There we go, and there we go. Nice. I like that. And actually, let me give it eyes. There we go. Nice. I really like this one. Now, another one. Well, just want to make sure. Alright, good. I changed it to art. I remember the incident where I forgot to change the art and had it at software for like 1.5 hours. That was not fun. Alright, next one. I think I'll do... I've done that. Which one should I do now? Actually, just a quick add-on to this. Let me just draw that so you can see where the bottom is on this character. Alright, nice. Right there. Now, which pose shall I do next? Ooh, I know. Let's do it here. Oops, this will be the body. There we go. I'll have it on this side this time. There we go. And one leg will go down. So let me quickly do that. Nice. One leg will be standing to the side. Or down, I mean. So, about there. And nice. And you need to stand on the toes now, so like so. Nice. All right. Actually, if I'm gonna have to do that with that leg now, let me get rid of this. Do this instead. Nice, I think that works. Because now I can do this. And a bit smaller, I think. There we go, and nice. And now we need to go in. So about there. There we go, and now for the foot. Yeah, something like that. And how are the arms supposed to be now? I have no idea, so I'm just gonna do something. But I actually think this works well. Yeah, I think that looks at least somewhat good. Doing it that way with the tilted line there. Alright. Now for the arms. Oh, let's do them that they meet like that. Yeah, let's do that. So let's do the head first. There we go. Very nice. Now for arms, let's start with this one. There we go, and nice. And now for the hand. Nice. I think that looks good. And now for this one. Very nice. Actually, I need to make this one a bit lower. So let me go erase that. Go and connect it from there. There we go. I forgot for a second that I did it like that on that side, so I need to do it on this side as well. There we go. And another thing I just realized is that this one needs to be like that. And now a bit too much. There we go, and yeah, I think that works. Very nice. All right, now let's do another one, and I know what to do. The main body will go like so. All right, now. Right, that will be the main body. Now for the lower body, I want one leg to go like so, and the other one going down. So let's actually make it this one goes like so. But to do that, I need to model the lower body in a good way. So like so. Alright, like that. And actually this needs to be a bit smoother, I think. Or a bit round. There we go. Actually, if that one goes down like that, I can show it here that this one goes a bit more down, I think. It can be a good little experiment. So I need to go... And if I now just draw that, all right, I think that can look interesting. Of course, all of that will be gone with me doing the leg, but that's fine. All right, so this one goes like there, there, and there. Nice, and all right, and since you won't see that, I think I will have to do like that. Right, I need to get rid of all of this as well. It's distracting me. All right. Yeah, I don't like how to do this. Actually, let me get rid of all of this for now and go back to how it was from the start, like this. Actually, let's do this instead. If I have it like this, it was an interesting idea, but I'm not gonna do it. If I do like normal, like so. There we go. I think it's simpler if I simply... Hmm. What happens if I do like that? And now from here, man, this is harder than I thought. Alright. Let me do the other leg first so I know what so I can see what I'm trying to make. Alright, so that one, let's see, that, so about here. And there we go. And there we go. Now right, I think that can look a bit better. And now yeah, I think that looks good. And now, how am I supposed to do this? Ooh, wait a minute. I got it. I'm cooking. If I drag this one out again, and then do that. So it goes like so. There we go, and now alright, if I do it like that, wait a minute, let me see about this. If I instead do this, and just so I can get an idea of how this will look. Like so. I can now connect that to that. Very good. And now let's erase this. And it's crazy to think that I just forgot how a leg works. Jesus Christ. Yep, that does not look good, because I forgot how a leg works. Right, because... let's see. If that one were to go, the knee would be on this side. So instead of trying to do what I wanted to do like that, let's just make it go up. There we go. I actually think with this, I can make this a bit more like this. Like so. And now for this. There we go. Nice. Finally figure out how the leg works. Took me long enough. And for the hands, let's make them I don't know, let's just make them do an air, no, let me actually see, I tried doing that move in real life, it did not work. I'm not that flexible. But I did get an idea. Alright, let's see. If I do the head first, it will go like so. There we go. I can make that better. Actually, yeah, I'll keep it like that. There we go. There we go. Very good. And now let's just all right. Let me make this edge a bit better. All right. And for arms, I think I'll do them like they. I'll think a bit about it, but I can't really think when I need to go to the bathroom, so I'll be right back. Alright, I'm back. The glove is back on, and I do have an idea as to how to do what to do. Since this is about flexibility, I think I'll try and do them so the arms connect like so, behind the back. So let me do this. There we go. Go. And I'll also think that I'll do this instead. Get rid of this. There we go. Very nice. And do and now do bam. Actually, let me keep it. Let me do this. All right, nice. And for the other arm. Oops, you don't mean to have erase on. Hmm. Let's see. If I erase this and make this a bit. Something like that, and now let's quickly do this, see how that works. Let me make that a bit shorter. There we go. There we go. That looks interesting. I'm fine with that. Actually, let me do one last fix here and just... There we go. Nice. All right. Right, that's number 3 down. What to do next? I guess I can do one that's sitting. Or, yeah, sitting. This will be the leg. This will be the body. Right. And then this leg will go upwards. So it needs to go like that. Something like that, maybe. I want it to be on this side like this time, so like that. There we go. And now for the next part. I can do it better. I can also make this part a bit smaller. About there. Yeah, I think that looks better. And now... There we go. Now this one needs to go... like that, I think. And I can make this one a bit shorter. There we go. And now... like that, I think. And this one will go... It's not like that, but it needs to be smaller. Yeah, I think that works. Alright. And now I think I'll have this arm going that way, this arm going up. So about there. There we go. And nice. Something like that, I think looks nice. A bit smaller. Very nice. And now this one will go down. Like that, I think, and right. And bam, bam, bam. There we go. I think that looks okay. And I want this one to look up towards there, so yeah, I think that looks okay. All right. That's number 4. And just out of curiosity, I want to see if it's raining outside. I think it did rain, but I didn't notice. All right. All right. What pose to do next? Huh. Actually, let me look up some ballet poses. That can be interesting to do. Let's see. Ooh. This one can be interesting to do. Yeah, I got one. So one leg goes down, the other goes 75 degrees. Same for that arm, and then one arm goes up, then towards the face. Alright, yeah, I can do that. That can be interesting to do. So, one leg will go down. Let me quickly do that one. And I'm thinking like so. Nice, and nice. Now for the foot, it goes like this. Something like that. Let me look at it again for just to make sure. Wrong way, alright. I put the foot the wrong way. I have it like this. Let me clean this up. The foot is supposed to be going in that direction, or like so. I also need to make this one a bit better. Yeah, let's have it like that for now. Actually, no. No. Let me just keep it like how it was. That's fine for now. Right, one leg goes like that, and the other one goes like this. Here we go. Let me just really quickly do this. Nice. And I think alright, something like that. And now right, and now Now just a quick. And let's just boop boop. Alright. There we go. Now for the head. It will point in that direction. So let's do that now. There we go. And now this arm will go out, then back in like that. Yeah, something like that. I like that. That's an interesting look. Alright. Now for the last one, I think I'll maybe one or two. What to do? Let me look at some more references. Let's see. What to do? What could be a good one? I think I see one. It will be a bit complicated, but yeah, I think I can do it. Alright, so one leg forward, then down 45 degrees, one leg just on the ground straight up. Then the main upper body, it will be leaning back in like a 90-degree curve. And then one arm up, one arm down 45 degrees. Then the head will be looking up. Alright, yeah, I can do that. Alright. So let me start with the leg that's going forward. We'll start like this. We'll go like so. And then it will go like so. So let me do that for now. And I think I'll put it down here. Right, now from here let me actually not do the whole thing here for now. Let me do that. And now from here. Something like that. And if I were to add this now, it could be like so. And yeah, I think that's all I need from that. Now this, I'll just do a quick there. There we go. All right, that will be this leg. Now for the next leg, it will be straight down. But before I do that, let me make a bit of the body. I'll make it from this. Something like that. I can make this a bit better. Like that, I think. And now for the next leg, it will simply be going down. So from here, and from here, there we go. And I think I'll do this. There we go. Actually, I think it will be better if I push this leg forward a bit. So if I do it like this, I'll have it go like that to there. There we go, and nice. I'm gonna erase this. And now a bit. There we go. Nice. And now come on. There we go. You know, this one will simply be going like this. Let me do this from another point. Like, there we go. Nice. And let me just really quickly look at the reference again. Alright, got it. Yeah, I got it. So this arm will be going in that direction and this arm will going up. Like that. Right, let's start with this one. There we go. Alright, something like that. That looks good. And now for this arm. And let me have my own little spin on this hand. There we go. Yeah, holy crap, this one is good. And now for the head. There we go. Yeah, I really like that one. Let me just do a quick fix here. There we go. Oh my god, I love that. I could have done the foot a bit better, but I don't care. That is beautiful. I'm actually happy with that. I'm done for today. I'm gonna continue doing ballet poses from now on because that is beautiful. I'm done for today with drawing. And now, with that, it's time to get my revenge on Melania. And after that, I'm gonna finally find a portal to Mog's palace. And depending on how long it takes for me to fight Melania, I will either fight Mog today or tomorrow. Because I don't think it should take that long to beat Melania. Alright. I'm gonna go on a quick break, get everything ready and all that, and then we will start playing Elden Ring. So, yeah, be right back. Alright, I'm back. It's time to play Elden Ring. So let me switch the category to Elden Ring. There we go. Let me turn off the music. And now, it's time to open Elden Ring. Very nice. Today I'm gonna beat her. I'm gonna beat Melania. And it will be glorious. Alright. Let's begin. Alright, so I'm here now at Melania. And before anything, I feel like I want to change a bit of this. Actually, no, let me try it once with what I have right now. But instead of that, let's see if I can change anything here. Alright, I can't, because if I do that, I will be heavy load, and I cannot have that. Alright. Let's do this. Let's see how this goes. Do this. Oh, come on. Nice. Oh, shit. Ah, damn it.
Blade of Mikola.
Alright. So, yeah, that is what's been happening so far, and I need to get better at dodging her. But something I'll do now, actually, is I think I'll go back to my old way of having things. So there we go. I want to try and go back to my old setup. So like this. This is my old build. The proper Viking outfit. I want to see how this works. I might die, I might not. Yep. Good. Oh crap. There we go. I fucking hate that move.
I am Melania,
Ah.
blade of Mikola.
Alright. Let's do this again. This is basically what we will be trying to do today. Just trying to beat Melania. Because if I can't beat her today, I think I will have to abandon her for now and try and get to Moog. Nice. Run away. Why did I attack there? Ow. You're gonna do that again, aren't you? Nope. Nice. I fucking hate that move.
I am Melania,
Oh, you're a bitch.
blade of Mikola.
Alright. Screw that, I'm going back to the heavy boy armor. So bam. 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 Alright. There we go. And I actually think that... I think it's better to have the jump, since I jump so much instead. Alright. I don't exactly have the time to do any charge attacks here.
I am Melania,
Alright, I got fucking
of
stomped.
Mikola.
Jesus fucking Christ. Just think that on my second try when I did this, I came like halfway through her second phase. And now I can't... Now that happened. Of course I missed.
I am
What?
Melania,
Ah!
blade of Mikola.
Ah. All right. Of course I missed that. Can you fucking stagger? Can you fucking stagger, please? Of course. Of course. Alright, finally made it to second phase. Oh, already? Oh, god damn it!
Consumed by the scarlet rot.
You know what? I'm gonna do it like this. I'm gonna try a few more times with flame, but if that doesn't work, I'm gonna use like blood or frost. Because it's taking way too much of my mental capacity to do this. That worked. Let me run because I know what you're gonna do. Oh, you didn't do it. Nice. Of course you did it now. The moment I do... Oh, phew. Come on, I know you want to do that shit. So just do it. Nice. Of course I missed. Nice. Come on. Ow. Yeah, god damn it. What did I not realize that was
The scarlet rot.
the river dance? Alright. But I think I'm getting a better hang of this. Of course. Ow. God fucking damn it, you bitch. Of course you do that. Of course you do that. Let me guess. If I run away now... Alright. Of course. You fucking bitch. Yeah, alright.
Blade of Nicola.
I knew that was not gonna work that time, and now that I realize it, I might as well switch the last two remaining blue flasks I have into red, because I'm not using that. There we go. Alright, what do I have here? Alright, I have more like to break stands. And alright. Let's see. Let me actually change this back to the charge. Okay. Let's see. Wait a minute, if I have this, just to see, can I? Yes, I can. Let's try this. Oh, wow. I'm gonna run away so I can heal. Wow. Thank you so much, bitch.
I am Melania. Blade of Nicola.
Ah. You wanna? Yeah. Right. As much as I hate to say it, it's gonna be hard doing it with this axe as it is now. But if I were to change this, let's see. Hmm. I mean, I do have blood and poison, all of that. Hmm. Let me actually quickly see what other weapons I have that are axe related. Hmm. I mean, I could use these two. Huh. Actually, just for fun, I'm gonna try using these. And solely focus on jumping attacks. That's gonna be an interesting thing to do. There we go. Now I need to make myself a bit lighter. I'll go back to Radon's outfit. And I'll have, I don't know. There we go. All right. There we go. Actually, let me try doing this. Nice. Alright, yeah. Let's try this for once. And see how this goes. Worst case scenario, I switch back. But since I'm not using fire right now, I might as well change that one to something else. Let's do... let's do... Let's do strength. There we go. Alright. Let's try this. And see how this goes. I just realized that I should have probably brought... Yeah, this is not gonna work for now. I fucking hate that move. Yeah, alright. But I think I got an idea here with the Dragon Halberd. So, actually, I think I'm gonna try using that for now. Let me get rid of that, and let's see. Go back to that. Nice. There we go. Let me rest and get some of my... Let's try this. Alright. Let's try this. Let's see how this works. I haven't leveled this up, so I might get... This might go completely bad, but doesn't hurt to try. Let me run away for a bit. There we go. Alright.
I am Melania. Blade of the
Yeah, no. I'm gonna do... Yeah, let me try and change my normal axe, because this is not working. It does not do enough damage. I'm gonna try changing... Actually, no. I'm gonna try this. I'm gonna continue with this. Let me use that. How does this look? No. Let me do this. Alright, there we go. Let me try this and see how this works. And since I'm back to this, I can get rid of the flasks again. Alright, let's try this again. Here we go. All right. Ah, damn it.
Consumed by the scarlet
All right.
rot.
Let's try this again. God damn it!
Blade of Nicola.
I can't do that. I can't get greedy like that. If I hit her with the whole hitting her on the head with the overhand, I can't just expect to just continue hitting her. Alright. I didn't even get a single hit in, or maybe one. Alright. Jesus fucking Christ!
Blade of Nicola.
I can do this, I just need to fucking focus. Finally. Run away. Come on. One more hit. Nice. Alright. Oh crap. Shit.
Let your flesh
Ah!
by the scarlet rot.
Alright. Let me think about this. If I were to go with like a different build on this guy, how would that look like? Because I don't really feel like doing that. Actually, let me quickly go to round table and see if I can do anything. Because I don't think I can beat her like this, how I am right now. What do I actually need to level up my axe?
Well, I took you for it no matter. It's lay out your arms.
I need 2 level 7. And then I need 6 more. Wait a minute, I can level up this one quite a bit. Let me actually do that. I need 2. That should be enough for a bit. All right.
Back already, no matter.
All right, I need 2 more. 2, 4, 6. So 12. No, 10. Let me sell some more
No matter.
runes. Just to make sure I can actually do this. There we go. Fours now. I need 10. Now 12 here. And 12 here. There we go. Let's see how much I can level up this now.
Back already, no matter.
And I'm not gonna do that because I need those. Alright. Now with that, let me actually look at something. I need that much to level up. What sort of spells can I use? Actually. I think it's time to bring out the dragon. And see how that goes for a tiny bit. Equipment. Actually, I can't do that since I still need... Actually, maybe. If I do that... Event 4 here. Spells. There we go. Let's try it again. See if anything has become better. Let me quickly just do a bit of... There we go. Nope. Nice. Let's see if this works. If I drink this... Nope, still can't use it. Shit. I guess there's no point in having that. But... Can I still not use this? Oh, God damn it, I didn't mean to sit down again. I don't know why I can't use this on I have no idea why I can't use that. But, Can I use this? Yes, I can. Alright. Let's try using this. That could be an interesting thing to do. What the? Wow, I did not have enough. Holy crap, that does a lot of damage. Of course.
Blade of Nicola.
But that is actually a pretty nice idea to have. Wait. Oh, I think I know why I can't use the fire. It's because I already have fire on it. Let's try changing this to blood. Or lightning. Yeah, let's try that. If I now go here and do spells, boop boop. Can I now use this? Wait, no. Let me try not having anything on it. Let's just do heavy. Can I now do it? Yes, I can. Alright, yeah, let's try this. Oh shit.
Blade of Mikola.
Actually, as much as I don't like it, I think it's time for a respec. And I think I know what to do. So let me go over here. Ah.
Is it thy
I'm gonna do fully on strength.
now?
So vigor needs to go up. Let me put it like there. Strength up. Endurance up. There we go. And for the last one, let's do one. There we go. With this, I'm going fully on damage and health. There we go. And now, let me change this back to fire. Actually, let me keep it at heavy. Let me change this into this. Alright, nice. Now, I need to quickly go pee before we start another shot of Melania, so I'm gonna quickly do that. See you, I'll be right back. Alright, I'm back. And now, with this, I can change my armor back into something heavier. There we go. Full heavy boy. I can get rid of this. And do that. Alright, nice. I can also get rid of the spells and this, since I don't need that. The spells can do that. Nice. Alright. And I do not need any... I do not need any of that, since I'm not going to use that. Alright. This is the loadout for now. Let's see if this will change anything. Full on heavy boy. With a big axe. Run away. Oh, come on. You bitch. And I'm dead.
I am Melania, Blade of
I actually think the fire thing is good here, so I'm gonna quickly change that back. Alright, let's go. And actually, let me change the poise thing back as well, because that doesn't really change. Let's do fire. There we go. Time to run. Shit. I need to look at her. Here we go. Oh crap. You know me to hit? Nice. Oh! Oh! Oh!
Your strength.
Yes!
Extraordinary.
Oh my god!
The mark of a true.
Oh my god! I beat her! Suck on my fucking Swedish meatballs, you bitch!
Dear Mikola.
Ah!
Dearest Mikola.
Oh my god. Thank you, Soris. And also welcome.
I find
Ah!
my match.
Oh my god. I am so glad I decided to change my loadout. Oh my god. Yeah, yeah, this boss really is only hard for because of one attack, that fucking river dance. But now he's gone. And she can burn in hell. Hello, flower. I don't care about you. Oh. Now let me level up more. And this time, now I'm done with that monstrous boss. Let me level up mine so I can start using my abilities a bit more. There we go. Nice. Oh, that felt awesome. And I'm gonna continue like this. Mr. Big Boy. Now I'm super happy. Because now, let me just quickly go over here. Take this. Thank you. Let me get all of these butterflies. There we go. Alright, and now, with that out of the way, I guess it's time to prepare for the DLC by going to Moog. But first, let me go back to Round Table and get her stuff. Ah. Let's see what she has for me. Nothing I need, so I'm gonna use her for runes. And oh, I forgot. I forgot about his armor. I forgot about all of this. Very nice. Let me see what I can actually get here, because there's a lot of nice stuff. Let me take that, and there we go. And there we go, and there we go. Nice.
Now go.
Now let's use her for runes. Very nice. That's a good amount. And let's use this as well. Oh crap, I need a lot more. Oh well. I think it's time to look at this a tiny bit, because I want that. There we go. instead of those, because they are pretty ugly with the weird looking feet, let's see what else works. This works. Wait. Ooh. Actually, like this. And actually, let me keep it like that. There we go. Nice. Wait. Just out of curiosity, how does this look? No, actually, I like this. I like this. Actually, yeah, let me just do full. There we go. Alright. Like this. Nice. And with that, I know a quick way to get more runes, so I'm gonna quickly go down here and make it so I can get another... What's it called? Remembrance. By taking down this place. I think it's easier to see. Oh, no. Is that enough? Nope. Is that enough? Oh, god damn it! And here I thought it would be easy, but I forgot. That's an insta-kill. Alright. Second try. Let's not get stomped by the giant turtle castle bullshit. That was close. You're gonna move that, right? Yep, knew it. There we go. There we go. And where's... There we go. Very nice. And now, let me get one of these. I think Rykard gave me more. So let me get one of his. Nice. There we go. Nice. Now let me do this. Very nice. Good amount of runes. Very nice. And with that, it's time to look for a Moog, which is the teleport to get to him is around here. So yeah, I will have to continue trying to look. But before that, I'm not really so happy about this strip I have. That looks better. Yeah, I like this. I'll go like this. This is nice. Alright, let's continue. Let's go over here. And let's see where he is. I'm just gonna go in this direction and just look around, see what I can find. The archers. There we go. Very nice. And now I also have one of the best capes in the game, which I forgot which I even forgot I had. Alright, let me look. Wait, is someone attacking me? There we go. Alright, let's see. In that direction. Alright, yeah. Let's try in this direction and see what I can find. Of course, one thing I know about this is that there's supposed to be Albernurics around it. Which means I should look for those frog-looking dudes. Let's try up here. There it is. Oh my god, I found it. I found it. Ha, so nice. All right, nice. Let's see where this takes me, because I've never actually done this one. So, oh. Hello. Oh, I'm here. All right. That's good to know. There we go. And now how do I get down here? Oh, here. All right. Nice. Oh, very nice. That felt good. I'm just so relieved now that I beat Melania, and I honestly did it faster than I thought I was gonna. Now, if I ever wanted to, I could cheese this bird by using arrows, but I don't feel like that's necessary. Alright. So I need to get over there to get to him. So let's just start writing. Actually, before that, let me quickly get some normal flasks in here and... Oh! I just remembered something I could possibly need for the... for Mog fights, but I don't think I really need it now. If worse comes to worse, I can go and get it later, but for now I don't need it. Ooh, nice. Hello, don't mind me, frogs. Don't mind me. Ooh, nice. Oh, come on, how did I miss that? Did I miss that as well? Ooh, a 7. What I needed. Jesus Christ. That was a bit too powerful for my taste. Nice. Very good. Now, I realized that there's something I could possibly need over there with the items, so I'm gonna go back and see if there are some 7s there that I could use. Because now I have 3, I need 1 more, and then I can upgrade my axe 1 more time. But before I do that, I'm not gonna risk my runes, so let me quickly use the hero runes I just got and level up 1 more time. I think this should be enough. How close am I now? Oof, I need 20,000. Alright, I'm almost there. Yeah, and like, I don't know. There we go. I think that's enough. Ah! I need 600 more. Alright. There we go. Nice. Alright. Now I don't have to worry about runes. Yeah. There we go. I'm thinking I'll try and get that to 20 and then I'll be done with my mind. Alright, let's go see what these items were. Because I would like to have them. Nothing there. Okay, nothing there. Jesus Christ. Here a rune, I don't need that. An 8, I'll take that. Anything else that's good for me? I don't think so. Actually, what's over here? Because I've never actually been here before. What's that? Oh, come on. Is someone invading me? Oh, white mask. Huh. Alright. That was a bit annoying. Now let me be very careful not to upset the bird. Because I do not want to make him mad. What so? Oh crap, dogs. Dogs! Oh come on, a leaf? Really? You know, let me just YOLO this. See what I can find. I do not need that. That's good. Oh, come on! Another person is... Right, you are being annoying. Oh, I'm here now. Rock grease. How did I not get that? You bitch! White mask, you're a bitch. Yeah, alright. I don't care about that. I got all the stuff I wanted. Wait. Oh, not for you. Alright, yeah. Right, now that I have this place, I can come back here whenever I want. So... let's see what... because there is some place I want to get to. Actually, what's here? I don't actually know what's here, so let's do that. Let's go here and see what we can find. Very good. Very nice. Right. Let's see what we can find over here. Alright, worm faces. Wait, what's over here? Okay, I don't really see anything important here. That was close. Oh, Mirage Rise and alright, yeah. Nothing I need here. But now that I think about it, I can try and kill Gold Mask again. I am a lot stronger now, so it should work. Alright. I need to just to be extra safe and see what happens. I'm gonna do all of this. Like this. Like this. Oh, come on. I guess I can't kill him. That's bullshit. Oh well. Let me try and... What do I want to do now? Let's see. What do I want to do? Yeah, you know what? Wait. Oh, yes. I know what to do. Let's kill White Mask. Since I'm already there, I don't need his... I don't need him. And since he was the one that called me maidenless, it stands to reason if I kill him, I will have maidens. That's how that logic works. Alright, let's go kill him. I think that's how that logic works, because if you kill the person that calls you maidenless, it will prove that they were wrong and you will have maidens. So yeah, let's go kill him. I think that's some good logic. Let's do this. Goodbye.
Very well. If you, maidenless runt,
Oh, bitch.
who do you think I am?
You call me that even as you die? Burn in hell, bitch. Now you're dead. And now I have maidens. You can't see them, but I still have them. Ah, very nice. Now he's gone. And with that, you know what? Let's try and find Moog. And I think I'll do it like this, that I'll try and beat him today. And when I beat him, it will be the end of stream. I think that's a good way to end it. Right. And since I don't think I need... Actually, no, let's keep the stance break thing. Alright. Let's run up this place. And avoid the huggers. Or in this case... exploders. Oh. Thank you for the... Thank you for the 7. I needed that. Hello, giant ass glob. Very good. Make sure I can see. I think it's up here. I know there's some... Ooh, nice. I know there's a merchant there, but I don't care about him. Is it up here? Yes, it is. Nice. I went right. Yo, Stein, what's up? Hope you're having a good day. I am having an amazing day because I beat Melania. So I am super happy right now. And now that I have this, yes. Let me quickly go back to round table and level up my axe one more time. I'm happy, I'm happy. Happy, happy, happy.
Well, I took you for no matter it. Lay out your arm.
Alright, nice. I simply need some runes. That should be enough. Nice. Oh. Hello. I can level up more. There we go. Let me do that. There we go. Nice. That is what I wanted. Now let me go over here and buy some rune rings or whatever they are called. Nice. And to add to it, anything here? Nope. Alright. Alright. It's time. Let's try and fight Moog. Or Mogwin or whatever his name is. Nice. It's time to fight him. Let's see how this goes. Maybe I one-shot him, maybe it's another Melania situation, but yeah, let's see. Alright. Bam, bam, bam. Nice. Alright. Hello, Gateway to DLC. I hope you're having a good day, because I am. Ooh, is that emotional damage? That's a really good flavor. Man, you must really love that flavor to bathe in it.
Dearest Mikola. You must abide alone a while. Welcome, honored guest, to the birthplace of our dynasty.
Alright. Let me kick your ass. I don't know why I can't use you, but that's fine. Bring it on, bitch. Oh, God, I'm not doing much damage. That's doing a good amount. Ow.
Trace.
Wait, I'm not double-handing? Alright. Ow. Ow. There we go. Very nice. Come on. Slowly chipping away. Ow. Did not think it was gonna do that. Ow. Shit. There we go. Oh, come on. Too early? Ow. Alright. Ow. Ah, damn it.
It's mine and mine alone.
Alright. Made it to second phase. This will be a lot easier. I simply need to get better at dodging his movesets. Oh, oops. Here we go. Ow. Come on. Ow. Shit.
Thrice.
Come on. Get over here. Ow. I can't keep forget about the third attack. And now I'm just losing. Alright, yeah, just kill me. Come on. Nope, let me get my runes. Alright, there we go.
Nicola is mine and mine alone.
Firstly, I don't think fire is that good against this guy. So let me go back to the grace real quick and change it to heavy. Because I think that's a bit better, hopefully. Alright, so Azure War, change that to heavy. There we go. Nice, and for flasks, I only need one. There we go. Alright, let's try this again. I need to call this thing down again. Oh, I need to call this thing down. It takes a while. Nice. Very good. And I realized I should have probably changed this back not to fire, but oh well. Bring it on.
Thrice.
Oh yeah, this is better. Oh, nice. This is so much better. Come on. Ow. That was close. Ow. Ow. Ah, damn it.
Mine and mine alone.
Alright. I can do this. A few more attempts, and I can do this.
Thrice.
Nice.
Almost.
Ow. Come on. Ow. Nice. Ah, alright. Ow. Ah, damn it.
Mine and mine alone.
Alright. Next try, I got this.
Thrice.
There we go.
Bonus.
Nice. Come on. Ow. If I can hit that move. God damn it.
Nicola is mine and mine alone.
Why do I set myself up for bad karma by saying I'll get it on the next try? That never happens. I say it will happen on the next try, but of course it does not. Alright. Let me not use one of the rune arcs. Let me just go and kick his ass. And let's not be so power hungry as to just attack him randomly. That should not have hit me.
Thrice.
Oh, come on. Nice.
Bonus.
Ow. Ow. That was fucking close.
Nicola is mine and mine.
Why do I say words like that was close? Because that shit happens. Oh, why? Why do I say such words? Ow. Why do I not remember that?
Thrice.
That's bullshit. Come on. Now remember that at least. Ow. I would really love a stagger. Really? No stagger? Ow. Oh! Oh my god, yes!
I can see
Suck on my Swedish meatballs!
as clear as day. The coming of our dynasty. Morgwyn.
Oh! So nice! Ah! Very nice. And now, I am ready for the DLC. Nice. There we go. And now, let's give Dexterity some extra love. Ah, nice. And now, I simply need to wait for the DLC. But yeah, I think that will do it for today. That was a really awesome stream. And yeah, we did quite a lot. We beat Melania, thank God. And we also beat Moog. So that was also very nice. Very, very nice. Alright. And now I think it's time to raid. And the person I want to raid today is Piffle, because I was not able to raid them last time. So, yeah. Today we will be raiding Piffle, who is currently drawing something. Let me go check what she's doing. Alright, she's drawing emotes. Alright. But yeah, with that, I think it's time to raid her. So let's start the raid, shall we? Let's start the raid. Boop. Let's do following. Let's do Piffle. And let's start the raid. Let's see if this works. It should. It may take a while because I feel like this new system of rating people is a bit wonky. Come on. Why won't you work? I really don't like the new way you raid people now. I much more enjoyed the last one. Oh well. Since that's not working, for some reason, let me try it one more time. Nope. Alright, it's being difficult, so let's raid Fufu, since she, for some reason, that's not working. So let's raid her instead. Alright, let's raid Fufu. A good and a very good choice when you don't know, when others don't seem to work. So yeah, let's raid Fufu. There we go. That's working. Very nice. And so yeah, with that, I want to thank everybody who's been here today. It's been very amazing. And yeah, not much else to say except I am super fucking happy that I beat Melania and Moog in the same stream, which was very nice. And yeah, with that, I want to thank everybody who's been here today, and I will see you all tomorrow, where I won't know what to do in Elden Ring. So yeah, with that, thank you all for being here, and I will see you all tomorrow. Later!